write a program to find the largest of two numbers without conditional operator. Finding the largest number with a conditional operator is very easy, but without a conditional operator, it's slightly tricky. So I'll give you the steps of implementation. So first let me take some sample values. Let's say A is some 50 and let me take B as some 60. Here the step 1 is we need to do a subtraction, and I'll store it in a third variable some z, which is A minus B. Something like if I substitute, it is 50 minus 60. Here we get z as basically minus 10. So this minus is basically an indication. If we get a minus, it means that the first number is smaller, right? But there's no point of using an if. So instead of using if, we'll be using a bitwise operator to find out in the last bit whether it is positive or negative. So here you need to understand the machine logic. Generally, the machine understands a number to be positive or negative based on the bits. So a number is basically 32 bits. The first bit, or like if you take from 0 to 31, the last bit, I can call this as last bit. Based on this, the machine will understand it is positive or negative. It is minus 1 if it is a negative number, and it is 0 if it is a positive number. So we will also use the same logic. The step 2 will be, we'll be using a right shift operator. So Z will shift it by 31 bits so that we come to this particular point. Now at this point, if you try to print the Z value, either you will have minus 1 or you will have 0. Alright, next let's go to step 3. Here what I'll do is I'll convert this to 1 and I'll convert this to 0. There's no need of conversion actually, but as per the logic, we'll retain the value of 0. And these two values we'll be using in the program. For this, what I'll do is we'll use a conversion with bitwise AND operator. That's basically Z and 1. We'll AND it with 1. Let me not take this as Z. Let's say this is some I, and I'm going to use I with this AND operator. So here there are only two possibilities. Either this I is either minus 1 or it is 0. So minus 1 and 1 will give us 1. 0 and 1 will give us 0. So basically we are converting this to this. Step 4, this is the last step. Here we will use the max logic. So max is basically the A minus I into Z. This will work. Let's take an example and see. The first possibility is this one. A is 50, B is 60. So B is higher. If I try to substitute 50 minus I, when we do 50 minus 60, we'll get minus 1, and we're going to use this AND operator. So basically you'll get 1 as your I. So here it will be 1. And Z value, Z is basically subtraction of these two. So 50 minus 60 is minus 10. So this is 50 plus 10, so 60. And we already know 60 is the maximum number, and we got the result as 60. The other possibility is A could be 60, B is 50. Now let's try in this case. So again, max is A minus I into Z. So here A is 60 minus I. Here A is bigger than B. So basically we'll get into this positive logic. So you get 0 here, and again when we use this particular logic, again we'll get 0 here. So this is 0 into Z. Z is again, this is the one, subtraction. So 60 minus 50, that is 10. So 60 minus anything into 0 is 0. This is 60. So even in this case we are getting the maximum value. I hope you are clear with this. So here we are using the logic of shift operator and bitwise AND to get to the maximum value. Let's implement this. Find the largest number without conditional operator. Okay, for this we'll write it as a function. So int find max, let this be the function. In this I'll take the two numbers as parameters. So while declaring the variables, let's take it as A, B and max. Here enter first number, let's save it as A. Then enter second number, let's store it in B. Then we'll use find max function. We'll send this A and B, and in return we'll get the maximum value that we're gonna print it. Printf maximum number is max. Alright, so we got main function. Now let's directly go to the implementation of the find max. So int find max, let's take it as A int B. So here let's take int variable some z, as well as I need a variable I. So the first thing is, in z we're gonna take the difference of a and b. Then I, we will be storing the last bit or the 31st bit. So z we're gonna do the right shift by 31. Then here to convert it to the 1 or 0, we'll use a bitwise AND operator. So AND we need to do it with 1, but let me use the hexadecimal notation. So this is the hexadecimal notation for 1 itself. So we're just ANDing it with 1. Then we're gonna find the max. So max also, let's define it over here. Max. All right. So max is a minus I into z. I think this was the logic we have used while I was explaining in the slide, right? Now we're going to return the max. Okay, I think this should work. So for convenience, let me give the quotations. This is basically find the difference, then right shift and bitwise and with 1. Then figure out the maximum value with logic. Okay, let's compile this. Okay, no errors. Let's execute this. First number I'll give it as 50, second number is 60. Yes, it's working. Let's try one more. Now let's give 60, then 50. Absolutely working. I hope you got the logic. Here if you want to do it with 3 numbers, we can do that as well. So let me show it to you. Let's take C, then enter third number. I'll take it as C. So first we'll be using this, then again reuse that. So here I'll use max and C. First what we are doing is we are finding the maximum value between these two. Then whatever we get it, that we are comparing again with C, then we are storing it in max. So this should work. Let's try. So first number let's give it as 50, second number let's give 60, third number 70. Let's try one more. 50, 200, 30, 200. Absolutely working. I hope you're clear with this. It is slightly tricky, but if you can get the logic, it's an easy one.